Question 16 is about verifying trigonometric identities. It is the first in the writing part from the lesson 11.2. Here, these are some basic formulas which you must remember, especially the Pythagorean identity. Remember the different variations of this. Say cosine squared theta equals 1 minus sine squared theta, and so on. These are all basic identities, reciprocal quotient identities, Pythagorean identities. These will not be used much. You might use these Pythagorean identities and mainly the reciprocal and quotient identities. We will look into a problem. Now, this part of the problem, you should know they both are equal. They are identity. No matter what, we have to prove them. If you take your calculator and put theta as 30, both the sides will match each other. But that is not what we are doing. We have to transform it and get both the sides equal to the same term. How do we do it? There is a thumb rule. See, thumb rule. So, thumb rule 1. This may not work for all 100% of the time, not all the problems, but most of the problem. Thumb rule 1, get into sine theta and cosine theta from sine theta and cosine theta. Get all these terms into sine theta and cosine theta. What does this mean? Whenever you see this, okay, sine, leave that. Don't go to simplify that. Cosine, don't go to simplify that. Where you can see anything other than these, try to get them in terms of sine and cosine. Let me show you. Step 1 here. Let's take the left hand side, LHS. Let's transform this. What is secant exactly? It's 1 by cosine theta, right? Minus, what is tan theta? It is sine by cosine theta. Sine theta by cosine theta. Okay, now I can easily tell this is done. You don't even need to transform the left side. So here, you can, if you can see the denominators, cosine, it's the same thing. So I can write cosine theta together, and this will be 1 minus sine theta. That is equal to the RHS. Done. It's proved. This is a very simple problem. You may not get this in exam, but this is just a basic one. When you just try to transform these left side into sine and cosine, you automatically got the right side. Or if you wanted, you can even transform this side. If you wanted this, step 2 RHS. Say you got confused with this step. You don't want to do this step. Fine. Split this cosine to both the terms. 1 by cosine theta minus sine theta by cosine theta. Now what is it? Both LHS is equal to RHS. Step 3 would be compare both the sides. Okay, step 3 is compare LHS and RHS. Hence, it is an identity. Equation is an identity. That's it. This is a simple one. Let's go to more complicated ones. Here the step-by-step solution is also there. You can refer to it later. What about this problem here? Now again, I'll stick to the same thumb rule. Whenever I see terms other than sine and cosine, I try to simplify them. 1 plus step 1 here, LHS. What am I going to do? Tan is sine theta by cosine theta divided by sine theta plus cosine theta. See, the right side, we don't have much to work with. So we have to get this simplified now. You can see it's a whole number over here. There is a fraction. So what we can do is we can get the denominator same. How do we get this denominator over here? There's nothing. It's a 1. So multiply and divide by cosine theta. So when you multiply and divide by cosine theta to this 1, now you have a denominator of cosine theta. What happens over here? It's cosine theta divided by cosine theta plus sine theta divided by cosine theta. This entire thing divided by sine theta plus cosine theta. Now when we have same denominator, can we write it together? Yes, we can easily write it up. So cosine theta plus sine theta divided by cosine theta. The whole thing divided by sine theta plus cosine theta. Now here, this is the upper term and this is the denominator. It's, if I write it in terms like this, a by b divided by c. Okay. How do we simplify this? If you want to write them together only in numerator and denominator, this is going to be, this b falls down, isn't it? So it'll be a by b and c. So this is what's going to happen. And then if we have a and c, we can simplify them if there is any common term. Now if you look carefully here, sine theta plus cosine theta and cosine theta plus sine theta is the same thing. So I can cancel this off. Why? Because this denominator, this one will move down over here, and these both are in the denominator part. So what happens is, this is basically the denominator, right? The numerator cancels the denominator, they are same. So what is remaining now? It is basically 1 by cosine theta is remaining. What is 1 by cosine theta? It is secant theta. I have not used the right side. This is fine. You can stick to one side and solve to the other side. It's absolutely fine. And here we go. This is the answer. So that's it. These are the steps. Now we can do more elaborate steps using both the sides, but whichever you find it easier, just stick to it. Now this one was pretty simple as well. Only the part is, over here, you need to make sure that you get the denominator same. Cosine theta, and then you can have a common denominator, that is cosine theta, and above it will become cosine plus sine, and it cancels off. So that's how we solve this up. And here we see, you can start with the left hand side, and over here they have left it over here, and then they have gone to the right hand side and simplified it further as well. Over here this cancels off. The steps which I did was much easier than the solution over there. And this one over here, this is another problem. What do you want? Oh, there are 32 problems. So it's gonna be a long video, so do bear with me. I will try and solve all the problems, all the 32 problems. If you're thorough with this, just stop watching the video anytime you want and just practice it by yourselves. Now what about secant theta, cosecant theta equals tan theta and cotan theta? Secant is 1 by, sorry, it's cosine, cos theta, and multiplied with cosecant is 1 by sine theta, that is equal to tan theta is sine theta by cosine theta, plus what is cotangent? It is cosine theta, inverse of this, reciprocal of this, sine theta. Now then, what can we do over here is, let's try and simplify the left. Okay, this is another way to solve as well. It's a writing exam. You can solve it any way you want. You can start left and right side simultaneously, which I'm doing over here, or you can do left side separate, right side separate, whichever is easier. I personally follow this, solving left side and right side together, because I'm just writing it out and we can easily solve it. Now, left side, it's just multiplication. So I'll write sine or cosine, it's fine, whichever you can write it first, multiplied with sine theta. That's it. I'm not going to touch this much because I don't have much to work with. Here I'll leave this over here itself. What about this one? Can I take the common term? But this doesn't have cosine, this doesn't have sine. So what I'll do is I'll multiply this denominator up and down. That's cosine theta by sine theta. Sorry, it's the same thing. Cosine theta. This is cos theta. And what about over here is sine theta by sine theta. So what we have over here is, see, if we write it properly, it's going to be sine power 2 theta divided by sine theta cos theta plus cos squared theta by sine theta cos theta. Next, we can add them up, right? Sine squared theta plus cosine squared theta divided by, the denominators are same, so I can write them up together, sine theta plus cosine theta. Over here, I can write anything first, so I'm going to write sine theta, cosine theta. You don't need to do it, but I'm just doing this step. Now what happens? What is sine squared plus cosine squared? Pythagorean identity says it's 1. So 1 divided by sine squared theta plus cosine theta, 1 by sine theta, cosine theta. This is also the same thing, isn't it? You don't need to write it again and again over here. Over there only it's enough, but I'm just writing it over here. See, left hand side is equal to RHS. Therefore, The given equation is an identity. You can write this. The given equation is an identity. Is an identity. So this is you'll get full marks for this if you write so much. So you can write it in stepwise or directly. You can just write LHS and RHS. Don't write over here equal to, because they're not equal. We need to simplify and then we can tell it's equal. So this is how we can solve this one. Let's look into more problems over here. Here as well, all the worked out solution is there, and then you can just compare both the sides, and here we go. The next problem over here, we have 2 sine square theta minus 1. There is sine theta, cosine theta. Okay. Now you can start from here, but it's going to be very, very difficult. You can see there is already a square at the right side, right? So here we have to do some manipulation. This denominator, take it to the other side, and then if I start multiplying, I'm going to have a square. Otherwise, there is no way I can get a square, right? I have to just multiply sine both the sides, and it's just going to be complicated because there is sine over here. So what I'll do is this, I take it to the other side. What's going to happen? It's going to be sine theta plus cosine theta multiplied with sine theta minus cosine theta. That is equal to 2 sine squared theta minus 1, isn't it? Here, what identity can you use? It's like a plus b, a minus b, that is equal to a squared minus b squared. Or you can start multiplying like distributive properties. Sine times sine, it'll be sine squared. See, both of them can be used. I'll do it by multiplication, because if you forget this identity in the exam, I can't directly write it. So sine is multiplied to both the terms. It's going to be sine power 2 theta minus, because there's minus here, sine theta cosine theta, plus this is multiplied to both the terms, cosine theta sine theta minus cosine and cosine will be cosine square theta. Now this minus and plus can be cancelled off. So what's remaining is sine square theta minus cosine square theta. Now when you have the same terms repeated but plus and minus is there, we can use the term. The first term over here is squared minus the second term squared. So directly we can get it from the identity without this step if you know the identity. So that is equal to 2 sine square minus 1. Is it true? No, but we have sine square here. What can we do? How can we remove this cosine square and get in another sine square? Because we need 2, right? So what I'm going to do is, I know the identity of Pythagorean identity, sine square theta plus cosine square theta is equal to 1, isn't it? So this is the identity, is equal to 1. Now I'll remove this sign to the other side. It's going to be cos square theta equals 1 minus sine squared theta. So can I substitute instead of this cosine 1 minus sine squared? Because I need sine squared theta here. There's no cosine. So I'm going to remove this off. So it's going to be sine squared theta minus, open the bracket, because cosine is 1 minus sine squared theta. That should be equal to sine squared theta minus 1. Let us multiply the minus sign here by distributive property. So it's going to be minus 1 minus minus becomes plus sine squared theta. Now sine and sine, there are two signs plus right over here. Both are positive, so it'll be 2 sine squared theta minus 1, which is equal to the right side, which was also 2 sine squared theta minus 1. So left hand side is equal to RHS. This is an equation and an identity. This is how we solve it up. Here, yeah, that's it. So just make sure you remember this, because we could not do anything at the left side to get in terms of squared. So we just take this below term to the other side and multiply, and we'll get a square, and then you can manipulate it a little bit and get the answer. No matter what, these are identities. They have clearly mentioned, verified each equation that each equation is an identity. So you can use your calculator as well. Put some angles, say 30 degrees every way. Both the sides will match. So here is the worked out solution. You can go through it in your own time. You can pause the video, go through it. And here as well. Okay, instead of all that, just follow the method which I did. That was more than enough. Here we have sine theta plus cosine theta whole squared. Now, when you have this whole square, there is no way you can do it without the identity. So the identity of a plus b, the whole squared formula is a power 2 plus 2 times ab plus b power 2. If this was minus, this middle term becomes minus 2ab. Now it's all positive over here because it's a plus b, the whole square. So let's use the identity. The first term becomes squared, that is sine squared theta plus 2 times sine theta, and we have cosine theta, and plus cosine squared theta. So this is the simplification of the left side. Now what can we do with the right side? Wait a minute, I can even simplify further over here. What is sine squared plus cosine squared? It's 1, right? See, if I write this up together, sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Here this becomes 1 plus 2 sine theta cosine theta. So this is the simplified version of the left side. Now let's see the right side. What can we do over here? This is equal to, here what we have to do is first apply all the reciprocal identities and get in terms of sine and cosine. That's the thumb rule, isn't it? Here secant becomes 1 by cosine theta multiplied with 1 by sine theta. Divide this entire thing by again 1 by cosine theta multiplied by 1 by sine theta. Now here when we simplify, I'm just gonna, it's better to do this as step 1 LHS, step 2 RHS, the right hand side, because otherwise it'll be messy because there are many steps for each of them. It's not the equal steps. Now here what we can do is, we can find, see the common denominator, we can just write it up together, 2 plus 1 by sine theta cosine theta. Now what about this below 1? Same thing, it'll be 1 by sine theta cosine theta. But here this is the problem. This denominator, we need to get it as common, but it doesn't have anything. So multiply this up and down. It's going to be sine theta cosine theta divided by the same thing, sine theta cosine theta. And now what we do is, we have the common denominator, so we can rewrite them together. So here it will become 2 sine theta cosine theta plus 1. Why? Because these two are having the same denominators now, and divided by sine theta cosine theta divided by again 1 divided by sine theta cosine theta. Now here, look, this is in terms of a by b divided by c by d, isn't it? Can we cancel b and d? Yes, absolutely, because if we write them up together, if this goes up, it becomes a reciprocal, right? A by b multiplied by d by c. So these two will join up together and these two will be up together. So here b and d can be cancelled if they are same. Now the same thing is happening here. B and d, they're same, so I can cancel them off. And what is remaining here? I'm remaining with 2 sine theta cos theta plus 1. What about the left side? I'll write 2 sine theta cos theta first plus 1. It's the same thing. So left hand side is equal to the right hand side. Hence, this is an equation and an identity. So that is how we solve it up. And we can see the steps as well. You can go through this later. You can just pause it and you can go through it if you want. And that's how we solved it. Now we are in 24th, still plenty of problems to go. I hope by now, if you have understood, you're solving these by yourselves. Only if you want to, if you got stuck somewhere, then you can continue watching the videos and see how it is done. Now here in this problem, we don't have much to work with because it's cosine, sine, sine, cosine. Now, in such cases, don't be stuck. There'll be something to work with. Over here, you can see denominator is 1 minus sine theta. Whenever you are 1 plus sine theta in the denominator or minus sine theta, not in the numerator, when it's in the denominator especially, or even in the numerator, we can do it. We have a conjugate method. That means, see, look at this, cosine theta by 1 minus sine theta, right? I have to multiply it and divide with the conjugate. That is the same two terms but the opposite sign. So I'll have to do 1 plus sine theta over here divided by 1 plus sine theta over here. Why do we do that? So now here it is a minus b, a plus b. We can use the identity a square minus b square. If you start multiplying it, you're remaining with only the square of the first term minus the square of the second term. So here we have cosine theta that is multiplied with 1 plus sine theta divided by 1 square minus sine square theta. What is 1 square theta? 1 square, sorry. It's 1 itself, isn't it? Cosine theta into 1. See now, keep your eye on the right side as well. I got 1 plus sine theta already, so that is a good thing. Now we don't have to bother about that. I'll keep the cosine outside. I'm not going to multiply it inside. Here I have 1 minus sine squared theta. Now, what is 1 minus sine squared theta? From Pythagorean identity, we know this is cosine squared theta. So, cos theta into 1 plus sine theta divided by this thing is cosine squared theta. This cancels, and you're remaining with 1 plus sine theta divided by cosine theta. That is equal to the right hand side, isn't it? I didn't even have to touch this. I got this answer. So this is how we do it. There is another way. You can even multiply the right side with 1 minus sine theta by 1 minus sine theta, and then you will ultimately get this. See, the denominator, this is there. Here it changes to cosine squared theta, cancels off, and you will get this answer. So whenever there is two terms, remember to use the conjugate, and that is how we can solve it up. Here we can see the methods are all there. Now here they've used different methods, a little complicated. No need of this. Whenever you see the two terms, just use the conjugate. That is generally how we can easily solve it up. And then they're comparing the two sides. Okay, it's just too lengthy over here in the solution set. But this one, which I just now showed here, is pretty easy compared to that. 25th problem. So after this, there's 7 more to go. Cosine theta, that means let's get it in terms of sine or cosine. Sorry, it's not cosine, it's cosecant. It's 1 by sine theta minus 1. That is equal to, what is this? It is, cot is cos squared theta by sine squared theta divided by over here 1 by sine theta plus 1. Now just remember, when we are solving these, there are various different methods to solve this. Which I am doing is just by following some thumb rules and just going on. There are other methods as well. Now over here also you can try conjugate and whatnot. You can do that. There are plenty of ways you'll get the same answer. You don't need to stick to the method which I'm teaching, but I feel what I'm doing is as simple as possible. You know, sometimes it might be longer, but it might be easier as well at times. So here, this is done. So what next? I have 1 by sine theta minus 1. Over here there is, I can remove it to the other side and do a lot of things. But before that, okay, whenever you see like this, same term minus and another term, same term plus another term. It is very easier if you move it to the other side. Then we will have 1 by sine theta minus 1. This is one term. 1 by sine theta plus 1. See, there are some hints whenever you see such things, you know, you can do that. Also, you can do the conjugate here. I'll do that other method as well because now I realize there is two terms. We can do the conjugate here. But you need to know Pythagorean identities of cosine square theta and stuff. Now here what is remaining? It is cos square theta by sine square theta, right? So what about this one? Let's multiply, I mean, not multiply, it is a minus b, a plus b. That is a squared minus b squared. So here it will be 1 by sine squared theta minus, what is the second term? It is 1 squared. Now here, we are not yet done, is equal to, this is, let's leave it for now. Whatever this over here we have must be brought to this term. Okay, what is this? This is 1 by sine squared theta. 1 square is 1 itself. Now let's take the common denominator. What do you do? Multiply and divide by sine squared theta, right? So here you multiply sine squared theta and divide by sine squared theta. So the denominators are same, so we are getting here sine squared theta in the denominator, and we will have 1 minus sine squared theta. What is 1 minus sine squared theta? It is cos squared theta by sine squared theta. Now it's equal, right? That's how it is. Now there are other ways also. What I was telling is this here, conjugate method. What conjugate? Now you don't need to do a conjugate method because this is there. You can just multiply it up over here. So it'll be cosecant. See, now here, without changing it to sine and cosine also we can solve. But as a thumb rule, I always change it. So I did in this method. But over here, what's going to happen is cosecant theta minus 1 multiplied by cosecant theta plus 1. That is equal to cot squared theta. Now here it's going to be cosecant theta squared over here minus 1 squared. That is equal to cot squared. And what is cosecant squared theta minus 1? If you remember from Pythagorean identity, cot squared theta plus 1 is cosecant squared. So if we take minus to the other side, this is going to be cot squared. Because cosecant squared theta minus 1 is actually cot squared itself. So cot squared theta equals cot squared theta. So now here, because I could recognize the Pythagorean identity format here, that's why I went with this. Otherwise, you can get it in terms of sine and cosine and then solve it up. Still, you will get the same answer. But this was the extra part, you know. But we have done the similar thing previously as well. So whichever is easy, you can go with that. And here you can see, here also they have gone with sine and cosine. And then, you know, compare both the sides. So here, that's the answers. Okay, it's again long. And we will look over here, comparing both the sides. Finally, they got both the sides as equal, and that's why that is an identity. Now, what about this one? We have cosine, cotangent. Now, cosine theta. I'll just go with the thumb rule over here because I can see cotangent, cosine, and there's nothing easy to solve. There's no power 2 or anything. So this will be cosine theta by sine theta. What about this? It is 1 by sine theta minus sine theta. We are over here, it's very simple to find the common denominator because it's multiplied, isn't it? So down, it's only 1 sine theta. Up, it will be cosine squared theta. What about this one? It will be 1 by sine theta. Here, you have to multiply and divide by sine theta. Why? Because up here, sine theta is there, but down there is no sine theta. So you have to do up and down. So it will be minus here sine squared theta by sine theta. Now we have the same denominator. So what's going to happen? Just write it once. Don't multiply this. It's minus here. So minus up, but denominators will be same. So if you're getting confused like this, imagine you have 3 by 9 and minus 4 by 9. You just solve the above terms, right? It will be 3 minus 4 divided by 9. The answer will be minus 1 by 9. Whereas if it was multiplication, it's altogether different. You know, you just write them out, cancel it out together. That's it. So when we have same denominator, we can write them together only once. And whatever is the operation up above, we write it above in the numerator. So the same thing. This we write it only once, and up is 1 minus sine squared theta. Now what is 1 minus sine squared theta? This cosine squared theta by sine theta. Is it correct? Yes. The left hand side is equal to the right hand side. Hence, this equation is an identity. This was pretty simple. And let's look into, okay, you can just pause it and go through it later on. That's the answers. Okay. We are in the 27th problem. Sine theta, cosine theta, tan theta plus cos square theta equals 1. Here sine, let it be as it is. What is cosine? Also again same thing. What is tan theta? Tan theta is sine theta by cosine theta. Then we have cosine square theta. Here what happens? This cosine is cancelled. What happens? Left side is sine square theta plus cosine square theta. Now here, look at this. Yes, left side, what is it? Pythagorean identity. Yes, it is equal to 1 is equal to 1. LHS is equal to RHS. I was thinking this is going to be a big problem because it was plenty, over here, many terms. But in fact, this is such a simple problem. All you did is tan theta formula, cosine cancel, sine squared plus cosine squared. This is 1. And even the right side, they want us to solve it for 1. So yes, this is an identity as well. Again, here you can see the same thing. They're splitting the terms and then getting it as 1. And conclusion, yes, this is an identity. This has been a very long video. If you're watching until over here, that means you're going to get great marks. I mean, you're trying very hard. That's very good. And if any one of my students from Aluruba is watching till here, let me know tomorrow, anytime this week, and I'll definitely give you some bonus marks, at least 2 bonus marks, because I would be really happy if you come till over here. I'm sure most of my students have skipped long ago. So if at all any of Aluruba students have watched till this part, then please let me know and I'll give you some bonus marks. Okay, going on to 28th problem. Now here we can see there is whole power 2. So it's like a minus b the whole power 2, right? But instead of that, first let's simplify how much we can, because it's cosecant and cotangent. And the thumb rule is to get in terms of sine and cosine, isn't it? So here it's 1 by sine theta minus, it's not sine. Tan is sine by cosine. This is cosine theta by sine theta, the whole squared. Let me try to simplify how much we can over here, because sine and sine, we can write it as common sine theta and 1 minus cosine theta. Okay, now what else we can do? We can split, no, this is already done. This is the whole square. Now, how about I'll split the square? I can split the square how? For the numerator and the denominator. See now, a by b the whole square. What happens? A squared by b squared, right? Same thing. I'll just split the square. It'll be 1 minus cosine theta, the whole squared, by sine squared theta. Why? Because this down also is power 2. So I can, whenever we write, see, sine theta the whole power 2 is equal to sine squared theta. We just write it over here for the sine. When it's whole thing, we just write sine squared theta in writing. Now then, how can see, right side we need 1 minus cosine theta. Okay, this is good. What we can do is we can split this out. See, what I'm doing is 1 minus cosine theta whole square means it's 2 times, isn't it? Again, I'll write 1 minus cosine theta divided by, over here, sine square theta. But look, I need cosine only. So from Pythagorean identity, I can write 1 minus cos square theta is equal to sine square theta. So I'll do that. So what I'm going to do over here is I'll write 1 minus cos square theta. Now look over here, there is square, there is no square. How can I split this? Look, a minus b, a squared minus b squared is a plus b, a minus b. So I'm going to use the same identity. This 1 can be written as 1 squared. It's the same thing because it's 1 itself, right? Now a squared minus b squared will be a plus b. That is 1 plus cosine theta and 1 minus, sorry, it's a minus b, minus cosine theta. And up above we have 1 minus cos theta and 1 minus cosine theta. So can we cancel? Yes, this can be cancelled. And is it? Yes, absolutely. We found the answer. It's 1 minus cosine theta by 1 plus cosine theta. This is the right hand side. So LHS is equal to RHS. So this is how we do it. I hope this is clear. That's the end of this problem. It was a lengthy one. It's not that difficult. You should just use the thumb rule. Always get in terms of sine and cosine and simplify how much you can. And now you look at the right side. What do we want is above it's fine. This one needs to be in terms of cosine. But here we have squared, so we can use the a square minus b square formula. Split it out. The terms get cancelled and you get the answer. See, as you put in the right formulas, eventually it will simplify to the other side. As you keep on continue to solve, it will come to the right side. So here we go. You can pause and watch this. Here also it's the same method. I mean, little variation is there. That's it. Okay. And here we go. This is a long one. Okay, they are comparing both the sides. Finally, they got the same thing. Rather than that, what I did over here is I took the left side and just straight continued till I got the right side. This is also absolutely fine. And this is a little easier because you don't have to simplify this to some steps. This one, no. I just took this one left side and came until over here. And here we have the next problem. Again, cosecant square theta. Cosecant is 1 by sine. Now square is there, so 1 by sine squared theta. That is equal to, what is cotangent? It is cos square theta by sine square theta plus sine multiplied by sine theta multiplied by 1 by sine theta itself. So here I can just cancel this off, right? Why sine and sine cancels off. So here what do we have is okay, now rather than doing this, I just realized the power 2 is very helpful. See, we can continue like this as well. We can, find the common denominator. You will get the same answer. But rather than that, there is such a easy method here. What is that? Here, if I keep it as cosecant square theta equals cot square theta. Now what happens here? These both are reciprocal and became 1, right? This is plus 1. Now look at this. Yes, this is identity. Cosecant square theta means it's cot square theta plus 1. This is the Pythagorean identity, isn't it? So we can just say that it's the identity, or we can tell this is also cosecant square theta. That's the identity. So it's not required to simplify. Even if you simplify, yes, you will get. Now here, that is the reason why I told the thumb rule works almost all the problem, not every problem. Here in this, you can do it like this, but it just takes you more steps. Rather than that, whenever you have power 2s like this, think for a minute, simplify some of the parts, and then you can easily get the identity. Then just stop it over here. In fact, for this problem, if you write this, you don't need to write this step. You just write this part here. Get this part over here. Say CSC square theta equals cot square theta plus, now sine theta multiplied by 1 by sine theta. And then if you write so much, write LHS equal to RHS. You must get the full marks. No need of this one. Just these. Even OE2 and the third one is more than enough. You should get full marks for this. So that is how we solve this problem. Here they have used a similar method, yes. And it's a little complicated here. But just use whichever is simple and which you are finding it easy. And yes, both the sides are equal. We're going to the 30s now, 30th problem. Here, secant. Secant is 1 by cosine theta minus 1 by sine theta. Now this is going to be taking common denominators. It's again 1 by sine theta multiplied by 1 by cosine theta. That should be equal to sine theta minus cosine theta. Now here I need to multiply sine theta by sine theta, so that I'll have the same denominators. Over here, what do I do? Multiply it by cos theta by cos theta. Well, because here cos theta is this, so this multiplies up and down in the other side. Sine theta is already there in the denominator, so it goes to the other side, up and down. Next, what we do is we just simplify how much we can. It'll be sine theta divided by sine theta cosine theta minus cosine theta divided by sine theta cosine theta. Entire thing is divided by 1 by sine theta cosine theta. Now here the above term is sine theta minus cosine theta divided by sine theta cosine theta. Why? Because these two are the same denominators. We write it up once, this minus here and left term and the right term. This entire thing is 1 by sine theta cosine theta. Now we have got similar problem just a while ago. We can easily cancel these both because this swaps and goes up to the numerator and 1 will be in this position denominator. So this and this cancels. You're remaining with sine theta minus cosine theta. Here LHS is equal to the RHS and hence proved. So that's how we solved it out over here. Let's look over here how they have solved it the similar way. Even over here, see, generally the same thumb rule is used. Whenever you have anything other than sine and cosine, you apply the reciprocal identities and try solving it. So over here, yeah, you just simplify it and you get the right side. So we compare, both are same. What do we do over here? See, this is sine square theta plus cosine square theta. This is equal to 1 left side directly. And what about this one? Secant square theta is 1 by cos square theta minus tan is sine square theta by cosine square theta. Now the denominator cosine square theta is together 1 minus sine square theta. Now what is 1 minus sine square theta? Now here, since the denominators are same, I wrote it together and 1 minus sine square theta. 1 minus sine square theta in Pythagorean identity is cosine square theta divided by again cosine square theta. Cancel this off, you'll get 1. Left side is already 1. Yes, LHS equals the right hand side. So this is how we solve it up. They're all pretty simple. Once you start solving a few, then you'll get a hang of it and then you can easily solve them up. And here you can see the left side and the right side, both will become 1. And yes, that's it. That's the answer. Okay, you can use other identities as well. Here, okay, they have just split this up. Secant square theta is 1 plus cosecant square, right? This minus and plus goes, so 1 remains. Even this is absolutely fine. But you need to know the Pythagorean identity of secant square theta. Now I remember, but when I was solving it just didn't come to my mind. But what I did over here is absolutely fine as well. And comparing both the sides, they are equal. Finally, the last problem in this topic, 32nd one. Let's do it very quickly. 1 by cosine theta minus cosine theta must be equal to, this is sine by cosine. That is equal to sine theta by cosine theta multiplied by sine theta. Now remember one thing. Once I remember, it's not now a long time ago, maybe the last year when I was doing the EoT or something, I had actually taken one single identity wrong, reciprocal. I can't remember exactly where, but I had gone solving it almost till the end and I was not figuring out. Only one was the issue. But then I realized, okay, initially I'd missed one single formula. You might continue, you might feel, okay, I'm getting it right because it's almost there, but you're not getting the correct answer. It might be to do with the formulas. So be very careful, check the formulas thoroughly before writing, and then continue. When you go to the next step, just double check everything. Yes, this is 1 by cosine, this is sine by cosine, and so on. Now we have to take the common denominator here. See, I'll write over here generally what we do is cosine theta minus cosine theta. We multiply and divide by cosine theta, that is this denominator, right? And then we can see this denominator is same, so we'll write denominator same, cosine theta. 1 minus cosine and cosine will be cosine square theta. But you can directly get this as well. There is a trick. This is no denominator. This has the denominator of cosine theta. So what you do is write the denominator here, cosine theta. Then this numerator of this is just written 1 minus. Now here this is written as it is. But to balance out the equation, you multiply this denominator to the numerator here. When I multiply cosine and cosine, there are two cosine. I can just put power 2. So I can directly get this. And equal, or you can just continue this because we have done it many times. Now here it's sine and sine, it is sine square theta by cosine theta, and 1 minus cosine theta is sine square theta by cosine theta. That is equal to the right hand side. So yes, this is also proven. LHS is equal to the RHS. Now if you write so much, you should get full marks. Nothing, no issues over here. That's how we solve it up. You can see over here the steps as well. The same steps, you can go through them. And that's okay. The steps over here are plenty, I think, so you just follow what I did. It's pretty easy, you know. Okay, finally, it is done. Both right hand side and left hand side are balanced. So this is how we solve this up. It is a bit lengthy, but just practice writing. Write more problems, solve more problems by yourselves, and then this is going to be pretty easy. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.